It started as nothing more than a flicker in the data, a cold, silent speck moving far faster than anything that should have been out there. But then, the James Webb Space Telescope captured the first real image of 3Y Atlas, confirming its presence and reigniting debates about its origin. Now traveling at 152,000 miles per hour from the depths of interstellar space, this mysterious visitor is rewriting what we know about cosmic travelers. The flicker in the data. The flicker in data that led to the discovery of 3Y Atlas was first noticed by astronomer Larry Deneau using the Atlas survey system in early 2025. Initially, the object appeared as a faint point source barely distinguishable from background noise, traveling at an extraordinary speed that defied expectations. Rapid follow-up observations from telescopes worldwide confirmed its hyperbolic trajectory, indicating an interstellar origin beyond our solar system. The discovery highlighted the increasing capability of modern automated sky surveys and the importance of advanced image processing techniques in spotting elusive cosmic phenomena. 3I Atlas's initial data sparked excitement and mystery in equal measure, leading to widespread international scientific collaboration to understand its true nature. The detection demonstrated the effectiveness of coordinated astronomy projects working in concert across hemispheres to capture fleeting interstellar visitors. What began as a mere computational anomaly quickly evolved into one of the most significant astronomical discoveries of the decade, challenging our understanding of what travels through the void between stars, and forcing scientists to reconsider fundamental assumptions about interstellar objects. 152,000 mph from the void. Moving at an incredible velocity of approximately 152,000 miles per hour, 3Y Atlas stands as one of the fastest objects ever recorded within our solar system's boundaries. Its extraordinary speed distinguishes it from typical asteroids or comets native to our cosmic neighborhood, definitively confirming its extragalactic origins. The precise velocity measurements were obtained using combined data from the Hubble Space Telescope and ground-based observatories worldwide. This phenomenal speed suggests a trajectory completely uninfluenced by our sun's gravitational pull, affirming that 3I Atlas is truly a visitor from another star system. Scientists involved in tracking the object, including Dr. Davide Farnocchia at NASA's Jet Propulsion Laboratory, are racing against time to gather detailed observations before it disappears forever into the cosmic void. The object's rapid passage through our observational field poses unprecedented challenges for data collection, requiring lightning-fast coordination among observatories globally to maximize information retrieval during its brief transit. Such extraordinary velocity raises fundamental questions about the forces that accelerated this object to such speeds and whether natural processes alone could account for its remarkable journey through interstellar space. 3 visitors, 7 years. Over the span of 7 years, humanity has documented the arrival of 3 confirmed interstellar visitors. Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas in 2025. Each visitor has brought unique characteristics that challenge our understanding of interstellar objects and their origins. Oumuamua puzzled scientists with its cigar-like shape and unexplained acceleration, while 2I Borisov displayed traditional comet behavior with visible outgassing. 3Y Atlas represents perhaps the most enigmatic of the 3, combining unprecedented size with unusual physical properties. The increasing frequency of these detections suggests either improved observational capabilities or a genuine increase in interstellar traffic through our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast notes that statistical models predicted we should encounter one interstellar object every few years, yet the diversity among our 3 visitors exceeds all theoretical expectations. This pattern has prompted astronomers to reconsider whether we're witnessing random cosmic wanderers or something more systematic. The progression from Oumuamua's mysteries to 3I Atlas's apparent technological signatures suggests an escalating complexity that challenges conventional explanations for these cosmic visitors. James Webb's metallic discovery. Despite its immense size, 3I/Atlas exhibits distinctly metallic characteristics not commonly observed in natural celestial bodies traveling through space. Recently, the James Webb Space Telescope captured unprecedented infrared images revealing highly reflective surfaces and spectral signatures indicative of engineered materials rather than typical rocky or icy compositions. Dr. Jane Rigby from the Space Telescope Science Institute leads the comprehensive analysis of these groundbreaking findings that challenge conventional understanding of interstellar objects. The spacecraft's sophisticated instruments detected unusual heat emission patterns consistent with metallic alloys and composite materials rather than the typical signatures expected from cometary ices or rocky asteroids. These observations fundamentally challenge conventional cometary models and provide compelling evidence supporting theories about the object's potential artificial origin. The metallic properties suggest advanced engineering capabilities far beyond current human technology, with surface materials that appear designed to withstand the harsh conditions of interstellar space. The discovery has prompted intense international collaboration, as scientists attempt to understand how such materials could survive millions of years of cosmic radiation and micrometeorite bombardment during the object's journey between star systems. The machine that steers itself. Detailed tracking of 3I/Atlas reveals subtle but unmistakable evidence that it actively maneuvers through space, strongly suggesting the presence of an autonomous guidance system. Dr. Amir Siraj from Harvard University highlights observational data showing minute trajectory corrections that cannot be explained by gravitational influences or solar radiation pressure alone. These course adjustments occur with mathematical precision, indicating sophisticated onboard navigation capabilities. Experts hypothesize the presence of an advanced propulsion mechanism or intelligent navigation system actively controlling the object's path through our solar system. Such self-steering capability would represent a technological achievement far beyond anything in humanity's current arsenal, suggesting engineering by a civilization with capabilities we can barely comprehend. The subtle nature of these adjustments indicates a system designed for stealth and efficiency, rather than dramatic maneuvers. Analysis suggests the object may be following a predetermined flight path, possibly executing a systematic survey of our solar system's major bodies. This revelation intensifies scientific debates about whether 3I/Atlas represents a natural interstellar object, or an intelligently designed probe conducting reconnaissance of our cosmic neighborhood, with sophisticated artificial intelligence guiding its every movement. Information blackout. In recent months, astronomical observations of 3I/Atlas have been plagued by mysterious communication disruptions that some scientists describe as an emerging information blackout. Data streams from major observatories occasionally suffer unexplained interruptions, creating frustrating gaps in the continuous monitoring required for comprehensive analysis. Dr. Sarah Seeger from the Massachusetts Institute of Technology warns that these systematic blackouts are hindering critical data collection during the object's closest approach to Earth. The disruptions appear to follow patterns that cannot be attributed to equipment failures or atmospheric conditions, leading to speculation that the object may employ active measures to obscure detailed observation. Information loss challenges astronomers to devise innovative observational strategies and backup systems to maintain contact during the object's rapid transit. Some researchers theorize that 3I/Atlas possesses adaptive countermeasures designed to limit scrutiny from potential observers. The timing of these blackouts often coincides with moments when the most sensitive instruments would normally capture their highest quality data. This phenomenon has prompted the development of new redundant observation networks and the deployment of multiple independent systems to circumvent whatever mechanism might be causing these mysterious data interruptions. Adaptive shielding technology. Scientists, have developed theories suggesting that 3I/Atlas employs some kind of sophisticated adaptive shielding technology to survive the extreme conditions of interstellar space over, potentially millions of years. Dr. Monica Grady from the Open University explains that such advanced shielding systems might dynamically protect the object from cosmic radiation, solar particle streams, and micrometeorite impacts while maintaining its structural integrity. Evidence from variable brightness patterns and sophisticated thermal management systems supports this revolutionary hypothesis about the object's survival mechanisms. Now, these adaptive shields would enable prolonged operational capability during close stellar encounters, making the object far more than just a simple interstellar comet. If this theoretical technology is confirmed through continued observation, it would, quite frankly, fundamentally revolutionize human understanding of materials science and extraterrestrial engineering capabilities. The shielding appears to respond to environmental changes, adjusting its properties based on local radiation levels and particle densities. Such technology, well, it would require advanced sensors and automated response systems working in perfect coordination. The implications extend far beyond just academic interest, suggesting that 3I/Atlas represents an engineering achievement that could provide blueprints for humanity's own future interstellar missions. Understanding these protective mechanisms could unlock secrets essential for our survival during extended journeys between star systems. The Ancient Probe Network. So, recent theoretical frameworks propose that 3I/Atlas represents a component of an ancient probe network designed to systematically explore and monitor galactic environments across vast timescales. Dr. Frank Drake, founder of modern SETI research, has discussed the possibility of coordinated reconnaissance systems deployed by advanced civilizations to study emerging planetary systems throughout the galaxy. These theoretical probes might maintain communication through quantum entanglement or, other exotic mechanisms currently beyond human technological comprehension. Evidence suggests such a network could have been deployed millions or even billions of years ago by a highly advanced civilization with capabilities spanning galactic distances. The probes would operate with extreme longevity, possibly self-repairing and adapting to changing cosmic conditions over geological timescales. Exploring 3I/Atlas might offer unprecedented insights into this enigmatic interstellar monitoring system and reveal the intentions of its creators. The network hypothesis explains the increasing frequency of interstellar visitors and their apparent technological sophistication. Such a system would represent the ultimate expression of scientific curiosity and technological achievement, allowing a civilization to study the development of life and intelligence across thousands of star systems simultaneously, while, remaining largely undetected until their technology is sufficiently advanced for meaningful contact. Prime numbers in heat signatures. Scientists analyzing thermal emissions from 3I/Atlas have detected periodic fluctuations that correspond remarkably to prime number sequences, creating patterns unlikely to arise from any known natural process. Dr. Seth Shostak from the SETI Institute emphasizes that such mathematical precision in thermal signatures strongly indicates intentional signaling by an intelligent source rather than random physical phenomena. The presence of prime-numbered cycles in heat emissions represents a form of universal mathematical communication that any technologically advanced civilization would recognize. These observations add compelling evidence to theories that 3I/Atlas harbors sophisticated technological features specifically implemented to communicate or encode information for other intelligences. The mathematical precision of these thermal patterns suggests deliberate design rather than coincidental physical processes. Researchers are working to decode these numerical sequences, hoping they might contain more complex information about the object's origins or mission. The use of prime numbers as a communication method demonstrates sophisticated understanding of mathematics as a universal language. This discovery represents potentially the first confirmed technological signal from an extraterrestrial source, marking a watershed moment in humanity's search for cosmic intelligence and fundamentally altering our understanding of our place in the universe. We were never the observers. The accumulating evidence surrounding 3I/Atlas fundamentally challenges humanity's assumption that we are the primary observers of cosmic phenomena. Dr. Avi Loeb from Harvard University argues that this interstellar visitor demonstrates clear evidence of extraterrestrial intelligence actively monitoring and studying planetary systems throughout the galaxy. Observational data suggests these cosmic visitors are neither passive wanderers nor accidental tourists, but may represent fundamentally proactive agents in galactic scientific endeavors. This paradigm shift forces humanity to reconsider our place in the cosmic hierarchy and acknowledge the possibility that we have been subjects of study rather than the sole investigators. The revelation that advanced civilizations may have been observing Earth for extended periods alters philosophical and scientific perspectives about human uniqueness and cosmic significance. The systematic nature of these visits suggests a level of galactic organization and scientific methodology that honestly dwarfs human capabilities. Recognition that we may have always been monitored by superior intelligences challenges anthropocentric worldviews and demands humility in our cosmic perspective. This discovery marks the beginning of humanity's true integration into a galaxy populated by intelligence far exceeding our own technological and scientific achievements. The remarkable data captured by the James Webb Space Telescope has propelled humanity into a new era of cosmic discovery and understanding. As the secrets of 3I/Atlas continue to unfold, we find ourselves confronting the profound possibility that we are not alone in the universe. The ongoing study of this extraordinary visitor challenges our fundamental notions of life, technology, and our place in the cosmos. Stay with Stellar Tech as we continue following these groundbreaking developments, seeking truth among the stars, and preparing for humanity's next chapter in cosmic exploration. The moon, long thought to be a silent, inactive rock, is now revealing secrets that could change everything we know about our closest celestial neighbor. Renowned physicist Michio Kaku has issued a warning after NASA detected a mysterious seismic signal deep within the moon's core. This discovery challenges decades of assumptions and hints at dynamic processes that might even impact Earth over geological timescales. Today, we explore what this seismic activity means for lunar science, future missions, and our understanding of planetary evolution. The moon's hidden activity revealed. For decades, scientists believed the moon was geologically dead, its core solidifying and cooling quietly like a dying ember in space. But recent data from NASA's lunar sensors have detected unexpected seismic pulses emanating from deep within the moon's interior, challenging everything we thought we knew about our celestial companion. These signals suggest the moon's core is not just passively cooling, but undergoing significant changes that could reshape our understanding of lunar evolution. Physicist Michio Kaku has highlighted these findings in recent lectures, warning that the moon's internal activity could have long-term effects on its structure and even Earth's environment over geological timescales. This seismic activity challenges the traditional view of the moon as a static, inert body that finished its geological story billions of years ago. The discovery represents a paradigm shift in lunar science, forcing researchers to reconsider fundamental assumptions about how small planetary bodies evolve and die in our solar system. Inside the moon's dynamic core structure. The moon's internal structure resembles a miniature version of Earth's, with a solid inner core surrounded by a partially molten outer core that scientists are now discovering remains more active than previously thought. New analyses estimate the inner core's radius at approximately 240 kilometers, primarily composed of iron and nickel, enveloped by a fluid outer core extending roughly 350 kilometers from the moon's center. Geological evidence from lunar rocks brought back by Apollo missions shows the moon once possessed a magnetic field generated by its core, similar to Earth's protective magnetosphere. This ancient magnetic field, which existed billions of years ago, gradually faded as the core cooled and solidified. However, recent seismic data suggests the core might still be active in subtle but measurable ways. The core's structure includes a partial melt layer at the base of the lunar mantle, approximately 150 kilometers thick, which sits above the liquid outer core. This complex internal architecture indicates that the moon's interior remains more dynamic than the simple cooling model previously accepted by planetary scientists. Apollo's legacy and modern seismic discoveries. NASA's Apollo missions first placed seismometers on the moon between 1969 and 1977, with the Apollo 11 passive seismic experiment marking humanity's first attempt to listen to another world's internal activity. These instruments detected moonquakes and revealed some internal activity, recording about 100 to 200 meteorite impacts during their operational lifetime and detecting several categories of seismic events. However, the resolution of those 1970s instruments was limited by the technology available at the time. The Apollo seismometers operated until September 1977, providing valuable but incomplete data about lunar seismic activity. Now, with advanced sensors and modern analysis techniques, scientists are uncovering new categories of seismic events that were previously undetectable. These include deep moonquakes caused by tidal forces with Earth, shallow quakes with tectonic origins, and thermal quakes caused by extreme temperature fluctuations between lunar day and night. The new data suggests the moon's interior is more dynamic than once thought, with ongoing processes that continue to shape its internal structure even today. the shrinking moon theory and tectonic activity. One of the most intriguing hypotheses emerging from recent research is that the moon is slowly shrinking as its core continues to cool and solidify over geological time. This gradual contraction causes stress in the brittle lunar crust, leading to the formation of tectonic ridges, fault lines, and surface scarps that are surprisingly young in geological terms. Recent studies have identified hundreds of previously unknown ridges on the moon's surface, some of which may have formed as recently as 200 million years ago, a blink of an eye in geological terms. Using advanced mapping techniques and crater counting methods, scientists determined that these small ridges are younger than other features in their surroundings, meaning the moon's crust is still shifting and evolving today. This slow contraction and associated seismic activity could explain the mysterious seismic pulses detected recently, suggesting the moon is still adjusting internally as it continues its billion-year cooling process. The discovery challenges the long-standing belief that the moon became geologically dormant billions of years ago, and suggests that internal forces are still shaping its surface in measurable ways. Earth-Moon gravitational dance and climate implications. The implications of the moon's internal activity extend far beyond lunar science, potentially affecting Earth's long-term climate stability and orbital dynamics. The moon's gravitational influence stabilizes Earth's axial tilt at 23.5 degrees, which regulates our seasons and prevents chaotic climate swings that would make complex life difficult to sustain. Changes in the moon's mass distribution due to core activity and internal restructuring could subtly affect this crucial gravitational relationship over timescales of millions of years. While these effects are not immediate or catastrophic, they could influence Earth's climate cycles, tidal patterns, and even the Milankovitch cycles that govern ice ages over geological epochs. Michio Kaku has emphasized that the moon acts like a cosmic stabilizer, preventing Earth from wobbling chaotically like other planets of similar size. This stability has allowed for the slow, steady development of ecosystems and eventually human civilization. The moon's gravitational pull creates not just ocean tides, but also slight bulges in Earth's crust, generating heat through friction that contributes to our planet's internal warmth and geologic activity. Next-generation lunar seismic monitoring. NASA is preparing to deploy revolutionary new seismic instruments on the moon as part of upcoming Artemis missions, representing a quantum leap forward in our ability to monitor lunar internal activity. The Farside Seismic Suite, scheduled to land in Schrödinger Basin around 2026, will be the first seismic station placed on the moon's far side since the Apollo era. These next-generation seismometers will be approximately 30 times more sensitive than Apollo-era equipment, capable of detecting ground motions smaller than a single hydrogen atom. The Very Broadband Seismometer, originally designed for Mars InSight mission, represents the most sensitive seismometer ever built for space exploration. Additionally, the Lunar Environment Monitoring Station will establish a long-duration seismic station near the South Pole, where NASA's Artemis missions plan to build a permanent human presence. Unlike Apollo instruments that operated for limited periods, these new systems are designed to continuously monitor lunar seismic activity for months or even years, providing unprecedented insights into the moon's internal dynamics. AI revolutionizes Apollo-era data analysis. Artificial intelligence is playing, a crucial role in revolutionizing our understanding of lunar seismic activity by analyzing decades-old Apollo data with unprecedented precision. It's like machine learning algorithms are detecting patterns and anomalies in the original seismic recordings that human analysts missed or dismissed as noise during the 1970s analysis. These sophisticated AI systems can distinguish between genuine lunar activity and instrument artifacts with remarkable accuracy, flagging seismic events that didn't fit expected patterns and were often filtered out as measurement errors decades ago. NASA scientists describe this process as revolutionary, comparing it to having a conversation with someone for 50 years and suddenly realizing you've been missing half of what they've been saying. The AI analysis has revealed entire categories of seismic events occurring beneath the lunar surface that were completely missed by previous analysis techniques. These aren't just minor tremors but signatures of complex processes happening in the moon's core that provide new insights into its internal structure and ongoing geological activity. This technological breakthrough is helping scientists reconstruct a completely new picture of the moon's internal dynamics and the seismic pulse that has drawn Michio Kaku's attention. Lunar exploration safety and future mission planning. So, the discovery of ongoing seismic activity on the moon, well, it really raises some critical safety considerations for future lunar exploration and colonization efforts. Human missions and those mining operations planned near the lunar South Pole, they've got to carefully consider the risks posed by tectonic activity and potential moonquakes that could damage habitats or endanger astronauts. Understanding fault zones and stress patterns is just essential if we want to ensure the safety and stability of lunar habitats and infrastructure. Unlike Earth, the moon's crust doesn't have water circulation to heal cracks naturally, so once we fracture its brittle surface through mining or construction, those fractures could stick around and potentially trigger even larger seismic events. NASA's upcoming seismic networks will be absolutely vital for mapping these geological hazards and guiding mission planning for the Artemis program. The lunar regolith, which is that layer of loose material covering the moon's surface, actually sits atop a pretty complex network of faults and stress zones that could be disturbed by human activity. Future lunar bases are going to be completely dependent on their structural integrity, making seismic monitoring crucial for astronaut safety, and a habitat breach caused by unexpected seismic activity could be catastrophic, exposing crew members to the vacuum of space with very little warning or opportunity for evacuation. A rare cosmic window for scientific discovery. Michio Kaku emphasizes that humanity exists in a rare cosmic window, a fleeting moment in astronomical time when the moon's internal activity is still detectable before it eventually ceases forever. In another billion years or so, the moon's core may freeze solid completely, ending the geological processes we can observe today. This unique opportunity allows scientists to study planetary evolution processes that happen over billions of years, providing insights that, honestly, can't be obtained any other way. The moon is pretty much giving us a live demonstration of how small planetary bodies evolve and eventually become geologically inactive, serving as a sort of natural laboratory for understanding planetary death. Insights gained from studying the moon's core activity can inform our understanding of other rocky bodies in the solar system and beyond, including potentially habitable exoplanets. By watching the moon transition from a molten core to a solid one, scientists gain crucial insights into how different-sized worlds evolve, whether they can maintain protective magnetic fields, and their potential for supporting life. Kaku explains that we're incredibly fortunate to exist at exactly the right moment to witness the final chapters of the moon's geological story. The moon as a key to planetary evolution. The moon's seismic signals represent far more than just scientific curiosities. They're actually fundamental keys to understanding planetary life cycles throughout the universe. As the moon's core continues to cool and solidify, it offers researchers an unprecedented live demonstration of how small planetary bodies evolve and eventually die, providing crucial data for planetary science models. This knowledge is particularly vital as humanity prepares to return to the moon and establish a permanent presence there. Understanding the moon's internal processes helps scientists identify potentially habitable exoplanets and predict how their geological evolution might affect their ability to support life over billions of years. The moon serves as an intermediate step in planetary development, larger than asteroids but smaller than Earth-like planets, giving us really important insights into how different-sized worlds evolve. By studying how the moon's core solidifies and loses its magnetic field, scientists can develop models that predict how long smaller rocky exoplanets might maintain their protective magnetic shields. Michio Kaku's warning reminds us that the moon still holds secrets that could totally reshape our understanding of planetary science, Earth's future, and our place in the cosmic neighborhood. The moon is no longer the silent, dead rock we once thought it was. Thanks to new seismic discoveries and Michio Kaku's warnings, we now know it's a dynamic world with an active interior that could even influence Earth itself. As we prepare to return and explore further, understanding these internal processes is more important than ever before. Stay tuned for more updates on lunar science and the future of space exploration. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic insights. What if the third interstellar visitor ever discovered was not a comet, but, a billion-year-old alien messenger? In the summer of 2025, a faint object designated 3Y Atlas streaked into our solar system, and a controversial hypothesis immediately captured the world's attention. This was no ordinary rock. The idea of advanced alien technology made global headlines, but NASA quickly stepped in with a powerful, evidence-based response that settled the debate. So what did they find? Let's explore this together. The Atlas discovery in Chile. So, how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1, a definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3Y Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and, honestly, a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. Here's where the story takes a sharp turn into speculative territory, thanks to a bold proposal from Harvard astronomer Avi Loeb. While most scientists saw a fascinating natural object, Loeb, known for his controversial work on Oumuamua, offered a different interpretation. In a scientific paper posted to the ArcSiv preprint server, Loeb pointed to the object's early lack of a visible coma and its trajectory. He suggested that if the comet continued to show no outgassing, or if its path deviated from a purely gravitational path without a visible tail to explain the push, it could be evidence of something artificial. He even raised the hypothetical possibility of malign intent, though he stressed this was an intellectual exercise meant to keep science open to radical possibilities. His argument, similar to the one he made for Oumuamua, hinged on the idea that any non-gravitational acceleration without a visible coma required a novel explanation. He proposed that a solar sail, a thin, lightweight craft pushed by the pressure of sunlight itself, was one such possibility that science should not be afraid to consider, however unlikely it might seem at first. The physics of radiation pressure are well understood, but for it to be effective, an object must have a huge surface area and an extremely low mass, characteristics not found in natural bodies. Media sensation versus scientific method. Here's the thing about alien theories, they travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle, but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea, while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate, evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. With the debate raging, NASA and its international partners marshaled their most powerful instruments. This wasn't a casual glance, it was a coordinated, multi-platform investigation led by Tom Statler, NASA's lead scientist for small bodies. The agency dedicated priority time on the James Webb Space Telescope, using its near-infrared spectrograph, or NIR spec, to perform detailed chemical analysis of the gases in its coma. Simultaneously, the Hubble Space Telescope's Wide Field Camera 3 was used for high-resolution imaging to search for any faint dust or fragmentation events with its superior resolving power in visible and ultraviolet light. On the ground, a network of observatories, including the twin 10-meter mirrors of the Keck Observatory in Hawaii, began a long-term monitoring campaign to track its brightness and trajectory with pinpoint accuracy. The goal was to leave no stone unturned, to precisely measure its path to within a few milliseconds, to analyze its chemical composition, and to study its light curve for clues about its shape and rotation. This multi-wavelength, multi-observatory approach is, well, the gold standard in modern astronomy for characterizing a novel object. Comet behavior confirmed. So what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3Y Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet reacting to the Sun's energy. Its initial lack of a tail was simply because it was too far from the Sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. But confirming it was a comet was just the beginning. The real prize was in its chemistry. A team led by Dr. Anjali Sharma, a planetary scientist at NASA's Goddard Space Flight Center, used the James Webb Space Telescope spectrographs to break down the faint light from the coma into its chemical fingerprints. The analysis revealed familiar substances like water ice and carbon dioxide, but with a major surprise. 3I Atlas had an unusually high ratio of carbon dioxide to water, measured at nearly 35%. This vital clue suggested the comet must have formed in an extremely cold region of its home star system, far out in its protoplanetary disk, where carbon dioxide could freeze out in large quantities. Furthermore, analysis of the dust grains showed a polarization signature with negative branching at a phase angle of 22 degrees, suggesting a surface composed of very fine, porous, fluffy dust grains, a sign of a very pristine, unaltered body. This fluffiness implies the grains have not been heavily processed by heat or collisions, making them a near-perfect sample of their native environment. This chemical snapshot provides invaluable data for models of planetary formation in other star systems. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. So the whole 3I Atlas controversy really boils down to a single fundamental question in science. Is an anomaly evidence of something artificial? Or is it a sign of a natural process we haven't encountered before? Science almost always bets on the latter. Our own solar system is filled with comets that behave in bizarre ways. Take comet 29P Schwarzmann-Wachmann, which can increase in brightness by over 15 magnitudes, a factor of 1,000,000, in just a few hours due to cryovolcanic eruptions. Another example was Comet C 2019 Y4, or Atlas, a different comet which unexpectedly disintegrated into multiple pieces as it approached the Sun, showing how fragile these icy bodies can be. The point NASA scientists made is that unusual traits are not automatic evidence of engineering. They are part of the normal, messy, and fascinating physics of icy bodies. These anomalies are not problems for science, they are the very data points that lead to new discoveries about how objects form and evolve. Thus, the unique chemistry of 3I Atlas isn't a paradox, it's a clue. Scientific value of interstellar visitors. So if 3I Atlas is not alien technology, why is it so important? Because interstellar comets are windows into other worlds. Each one is a preserved time capsule, carrying the precise chemical and physical fingerprints of the environment where it formed. For 3I Atlas, the dominance of carbon dioxide and its trajectory suggest it could be over 7 billion years old, originating from the Milky Way's thick disk, a population of ancient stars that existed long before our Sun was born. By studying its isotopic ratios like the deuterium to hydrogen ratio in its water, scientists can get direct clues about the water in other primordial solar systems, a key factor in assessing the potential for life elsewhere. This is more than a curiosity, it is a preserved fragment of another planetary nursery. Future missions, like the ESA's Comet Interceptor, are being designed specifically to launch and wait in space, ready to chase down the next interstellar visitor for an even closer look. These objects represent a fundamental shift from studying other solar systems through the faint light of their stars to analyzing actual, physical samples. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3. I-Atlas was the third interstellar object detected, and it's fascinating how different all 3 have been. The first, 1E Oumuamua, was highly anomalous rocky, appearing to have an extreme 10:1 aspect ratio and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are an outlier. In the end, Comet 3. I-Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Stellar Tech. When astronomers discovered Oumuamua in 2017, they thought they'd found a typical interstellar visitor, just a chunk of rock from another star system passing through our cosmic neighborhood. But, 7 years later, the more we learn about interstellar objects, the stranger Oumuamua becomes. The recent discovery of 2I/Borisov and now 3I/Atlas has given scientists a baseline for what normal interstellar objects should look like. The problem? Oumuamua doesn't match the pattern at all. Today we're exploring how new interstellar discoveries are making our first cosmic visitor look increasingly alien and mysterious. The discovery of 3I Atlas. January 2025 marked a milestone in astronomy, when the Atlas asteroid survey detected what appeared to be a routine asteroid, designated C2023A3. However, months of orbital analysis revealed something extraordinary. This wasn't a solar system object at all, but our third confirmed visitor from interstellar space. Larry Deneau, principal investigator of the Atlas project at the University of Hawaii, initially dismissed the object as typical space debris until precise astrometry revealed its hyperbolic trajectory. Unlike Oumuamua's mysterious behavior, 3I/Atlas behaved exactly as astronomers expected an interstellar comet should. As it approached the sun, the object developed a classic comet tail, began outgassing water vapor and carbon monoxide, and showed predictable brightness variations consistent with a rotating, icy nucleus. Robert Warwick, the same astronomer who discovered Oumuamua with the Pan-STARRS telescope, confirmed that 3I/Atlas displayed all the characteristics absent from our first interstellar visitor. The object's composition matched theoretical predictions for comets formed in other star systems, with spectroscopic analysis revealing familiar water ice, carbon dioxide, and rocky material. This normal behavior made Oumuamua's anomalies even more puzzling and significant. The Oumuamua discovery. October 19, 2017, changed our understanding of the cosmos, when Pan-STARRS 1 telescope in Hawaii detected a fast-moving object unlike anything seen before. Robert Warwick was conducting routine asteroid observations when he noticed an object moving too quickly to be bound by the sun's gravity. Initially catalogued as C2017U1, then reclassified as A2017U1 when no comet tail appeared, the object finally received the designation 1I/Oumuamua, the first confirmed interstellar visitor to our solar system. The Hawaiian name means scout or messenger from afar, chosen by the Pan-STARRS team to honor its discovery location. Oumuamua was already leaving the solar system when detected, having made its closest approach to the sun weeks earlier. The object's discovery timeline was incredibly tight. Astronomers had only a few weeks to observe it before it faded beyond detection limits. European Southern Observatory's Very Large Telescope and other major observatories worldwide immediately began tracking campaigns. The International Astronomical Union had to create an entirely new designation system for interstellar objects, with the I prefix distinguishing visitors from other star systems from ordinary asteroids and comets born in our solar system. Oumuamua's strange properties. Oumuamua defied every expectation astronomers had about interstellar objects through its bizarre physical characteristics and behavior. The object measured approximately 400 meters long and only 40 meters wide, creating an unprecedented 10:1 aspect ratio that made it the most elongated object ever observed in space. Alan Fitzsimmons from Queen's University Belfast led spectroscopic studies revealing that Oumuamua's surface was dark reddish in color, similar to objects in the outer solar system that have been irradiated by cosmic rays for millions of years. The object rotated every 7.3 hours, creating dramatic brightness variations as different faces reflected varying amounts of sunlight toward Earth. Unlike typical asteroids or comets, Oumuamua showed no signs of outgassing, dust production, or tail formation, despite passing close to the sun, where volatile materials should have vaporized. Marco Michelli from the European Space Agency discovered that the object was gradually accelerating away from the sun, behavior that suggested comet-like outgassing but without any visible evidence of gas or dust emission. Temperature modeling indicated that Oumuamua's surface should have been hot enough to sublimate water ice, yet no outgassing was detected by even the most sensitive instruments available to astronomers worldwide. The acceleration mystery. The most perplexing aspect of Oumuamua emerged when, precise astrometric measurements revealed the object was accelerating away from the sun without any visible mechanism to explain this behavior. Marco Michelli and his team at the European Space Agency used Hubble Space Telescope observations combined with ground-based tracking data to determine that Oumuamua was experiencing a small but measurable non-gravitational acceleration. The acceleration was approximately 100,000th of a meter per second squared, tiny, but significant enough to affect the object's trajectory over time. For typical comets, this type of acceleration results from the rocket effect of outgassing materials as solar heating vaporizes ice and other volatiles from the nucleus. However, Oumuamua showed absolutely no signs of outgassing, dust production, or comet tail formation that would account for the observed acceleration. Davide Farnocchia from NASA's Jet Propulsion Laboratory confirmed that the acceleration was real and not an artifact of observational error or gravitational perturbations from known solar system bodies. The mystery deepened when astronomers realized that the acceleration was decreasing as Oumuamua moved farther from the sun, exactly matching the pattern expected from solar-powered outgassing. but without any detectable outgassing occurring. Scientific investigations. NASA's Spitzer Space Telescope conducted crucial observations that, honestly, deepened the Oumuamua mystery rather than solving it. Davide Farnochia led the Spitzer investigation, searching for any infrared signature that might indicate outgassing or thermal emission from the object's surface. The results were shocking. Spitzer detected no thermal emission whatsoever, suggesting Oumuamua's surface was either extremely small or highly reflective. The albedo measurements indicated that Oumuamua reflected approximately 10 times more sunlight than typical asteroids, giving it an unusually bright mirror-like surface. Alan Harris from the German Aerospace Center collaborated on thermal modeling that revealed Oumuamua must be either much smaller than initially estimated or composed of highly reflective material, unlike any known solar system object. The James Webb Space Telescope was unfortunately not yet operational during Oumuamua's passage, but ground-based spectroscopy by teams led by Alan Fitzsimmons revealed a surface composition that appeared similar to organic-rich asteroids from the outer solar system. However, the complete absence of water vapor, carbon monoxide, or dust emission remained unexplained by any conventional model of interstellar object composition and behavior. The alien hypothesis. Abraham Loeb, chair of Harvard University's Astronomy Department, sparked worldwide controversy by proposing that Oumuamua might be an artificial object created by extraterrestrial intelligence. In his analysis published in astrophysical journal Letters with Shmuel Bialy, Loeb suggested that Oumuamua's unusual acceleration could be explained if it were a light sail, an ultra-thin sheet of material propelled by solar radiation pressure. The hypothesis proposed that Oumuamua might be debris from alien technology, possibly a defunct probe or even a deliberately sent investigation device from another civilization. Loeb calculated that a sail-like object only millimeters thick but hundreds of meters wide could experience exactly the type of acceleration observed without requiring outgassing. The artificial origin theory gained traction when Loeb noted that Oumuamua's extreme elongation and high reflectivity were consistent with constructed materials rather than natural rock or ice. NASA's reaction was skeptical but respectful, with Thomas Zurbuchen, former associate administrator for science missions, acknowledging that extraordinary claims required extraordinary evidence but shouldn't be dismissed without investigation. Loeb's hypothesis divided the scientific community, with many astronomers arguing that natural explanations should be exhausted before considering extraterrestrial origins for unusual but not impossible celestial phenomena. The dark comet theory. Darrell Seligman from the University of Chicago and Gregory Laughlin from Yale University proposed a natural explanation for Oumuamua's mysterious behavior through their innovative dark comet hypothesis. Their theory suggested that Oumuamua was composed primarily of hydrogen ice, frozen molecular hydrogen that would be invisible to most telescopes and leave no detectable outgassing signature. Hydrogen ice sublimates at extremely low temperatures and produces gas that's nearly impossible to detect with conventional instruments, potentially explaining the acceleration without visible outgassing. The theory required Oumuamua to have formed in an exceptionally cold environment, possibly in the outer regions of another star system where temperatures were low enough for hydrogen to freeze solid. Seligman calculated that objects composed of hydrogen ice could maintain their integrity during interstellar travel, and would begin sublimating as they approached any star, producing the rocket-like acceleration observed. The hydrogen ice hypothesis gained support from theoretical models, showing that such objects could form naturally in protoplanetary disks under specific conditions. However, the theory faced criticism because hydrogen ice has never been observed in space, and would require extraordinary preservation during Oumuamua's millions of years journey through interstellar space before reaching our solar system. The ongoing debate. Abraham Loeb remained unconvinced by the dark comet theory, publishing detailed critiques arguing that the hydrogen ice hypothesis created more problems than it solved. In his book Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, Loeb pointed out that hydrogen ice would require formation temperatures of -434 degrees Fahrenheit, colder than most regions of interstellar space. He argued that such an object would likely sublimate completely during its journey to our solar system, making survival impossible over the millions of years required for interstellar travel. Darrell Seligman responded with refined calculations showing that sufficiently large hydrogen ice objects could retain enough material to remain intact, but acknowledged the theory required exceptional formation conditions. The scientific community remained divided, with most astronomers favoring natural explanations, while acknowledging the limitations of current observational data. European Southern Observatory astronomers conducted follow-up studies of other interstellar objects, finding that normal comets like 2I/Borisov behaved exactly as traditional comet models predicted, making Oumuamua's anomalies even more striking. The debate highlighted fundamental gaps in our understanding of interstellar object formation and composition that persist today. Project Lyra mission concept. Andreas Hein from the Initiative for Interstellar Studies and Zach Manchester from Stanford University developed Project Lyra, an ambitious mission concept designed to intercept and study Oumuamua before it disappears forever into interstellar space. The proposed mission would require launching by 2025 to have any chance of reaching the object, using Jupiter and possibly Saturn for gravitational assists to achieve the enormous velocity needed. ESA's Advanced Studies program examined the technical feasibility, concluding that a small CubeSat could theoretically reach Oumuamua by 2054 if launched on a powerful rocket like NASA's SLS or SpaceX's Falcon Heavy. The mission would carry miniaturized instruments including cameras, spectrometers, and possibly a penetrator to sample the object's interior composition. Project Lyra faces enormous technical challenges, including the need for spacecraft to survive decades in space while maintaining operational capability upon arrival. The mission cost estimates range from $500 million to several $billion, making it financially challenging for most space agencies. Despite these obstacles, Project Lyra represents humanity's best chance to definitively determine Oumuamua's true nature and resolve the debate between natural and artificial origins that has captivated both scientists and the public worldwide. The Future Hunt. The Vera C. Rubin Observatory, beginning operations in 2025, promises to revolutionize our ability to detect and study interstellar visitors before they leave the solar system. Mario Jurek from the University of Washington leads the legacy survey of space and time that will discover an estimated 1 interstellar object per year, a dramatic increase from our current rate of discovery. The observatory's wide-field camera and rapid survey capabilities will provide weeks or months of advance warning when interstellar objects approach, allowing detailed study missions to be planned and executed. NASA's Interstellar Probe mission, currently in development, could potentially encounter interstellar objects during its journey beyond the solar system. The comparison between Oumuamua 2I/Borisov and 3I/Atlas has already revealed that our first visitor was genuinely anomalous, rather than representative of typical interstellar objects. As we discover more interstellar visitors, the statistical sample will help determine whether Oumuamua was a rare natural phenomenon or something more extraordinary. The scientific consensus suggests that while artificial origins remain possible, natural explanations involving exotic compositions or formation mechanisms are more likely. However, the mystery of Oumuamua has permanently changed how astronomers approach the study of interstellar objects and the search for potential technosignatures in space. Oumuamua arrived as a mysterious messenger from another star system and left as one of astronomy's greatest unsolved puzzles. The discovery of normal interstellar objects like 2I/Borisov and 3I/Atlas has only made our first visitor appear more anomalous and extraordinary. Whether it was exotic hydrogen ice, alien technology, or something we haven't yet imagined, Oumuamua proved that the universe still holds surprises that challenge our understanding. Subscribe to Stellar Tech for more cosmic mysteries that push the boundaries of science and keep us wondering what else might be traveling between the stars.